All right, hi bio students. I hope you're having a great day. I miss being in class with you, but hopefully this will be helpful. So the first thing that we're gonna do is we're going to review your exit ticket from Friday, which you should have. If you are absent, there should be extras in the classroom, so you can get one. And so in this, once you have this out, the main thing here, right? The problem asked you to, it was like your friend is drawing potassium chloride as an aqueous solution, and this is the diagram that they produce, right? And so you were asked to identify the mistakes. There were several, right? And so we're just going to go through them. So a couple things to remember is, first of all, metals form cations, which are positive ions. And so in this, right, compound is we have potassium is the metal. And you'll notice immediately that potassium has a -1 charge. So that should be a clue that something's wrong there. And so potassium is actually a +1 charge, and you would know that it forms a +1 charge because that's from the trend of the periodic table. So you should have your periodic table, and it's labeled with +1 over the group that potassium is in. So we'll put that there. The next thing that we want to remember is that nonmetals form anions or negative ions. And so in this one, we have chlorine, which is a nonmetal. And chlorine, similarly, you would look at the periodic table and you would find out that it forms a -1 ion. So in that group that has chlorine, you should have -1 laid over that. So those are two things, right? And then the last thing is this formula, KCl is great, right? Because potassium forms a +1, chlorine forms a -1, so overall that compound is neutral. And so in this drawing, you'll notice that your friend, or this, me, right, drew chlorine as diatomic. So something to remember is chlorine is a diatomic element, but it is only diatomic when it is by itself, right? So diatomic elements are only diatomic when they're by themselves. So hopefully remember that. And so in this drawing, we just want one ion, one atom of chlorine to appropriately represent that. And then I'm going to talk about water in a second. So first of all, based on what we talked about, like this is what your friend should have. And so you want to make sure that you can draw this and be able to do this. The last thing is, once you do appropriately represent potassium chloride as separate, how they drew the water molecules is then actually okay, right? So one thing to remember about water is it's polar, so it's slightly positive on the hydrogen and it's slightly negative on the oxygen. And so this would be great. They would do this and they would be fine, right? The oxygen slightly negative are around the positive cation. And so a couple other things, we know that there are 2 ions in this solution. We would say potassium chloride forms 2 ions in solution. And yeah, this is what it looks like. So screenshot this, draw it in your notes, correct it. Make sure that you can do this for compounds because you will be asked to do that. Appropriately represent water and the compound both as a solid or in solution. The next thing we're going to do is we're going to go over our homework. So why don't you go ahead and get your homework that was due today out, and then once you're ready, you can resume the video. Okay, so what I'm going to do, I'm going to just do like 2 examples, and then you should have an answer key that you can check the rest of these. So the first one is to give the name. So we're trying to give the name. And so what we see here, let's just do Na2O. Na2O is sodium. And so when we follow our naming ionic compound rules, sodium, you just put the name of the metal first, right? The cation, the name of the cation. And then for the anion, you add that "ide" ending. So we have oxygen, right? But it becomes oxide. And so the full name is sodium oxide. Another one that we can do is, let's do potassium. Actually, no, we just did an oxygen. Let's do silver fluoride. So silver is a transition metal, and you guys got into the habit of using Roman numerals to talk about transition metals, which is great. But silver is actually always going to form a +1 ion. And so because of that, it actually doesn't need a Roman numeral. And so similarly, it's just going to be silver and then fluoride. So fluorine becomes fluoride. And then we can do one more, right? Let's do barium, Bai2, right? So again, name the cation, just gets its name. Barium, no change. Iodine becomes iodide. Great. All right, these ones. So it's writing the formula for the following binary ionic compounds. So the best thing to do is to go to your periodic table chart and find out that lithium, its symbol is Li, and it is in the column that forms a +1 ion. Bromine, its symbol is Br, and it is in the column that forms the group that forms a -1 ion. So in order to have an overall neutral compound, you only need one of each. Let's do aluminum fluoride. So aluminum, you would find out its symbol is Al, and it forms a +3 ion. Fluorine, its symbol is F, and it forms a -1. So in order to have an overall neutral compound, you need 3 fluorines. So the formula would be AlF3. Okay. Now we're going to do transition metals ones. So transition metals, we use a Roman numeral to describe the charge on the cation. And we know that when we are given the formula. So when we look at this one, we'll do chromium oxide. So this formula is not incorrect. It's correct. And so based on this, you would say, okay, chromium, great. What is the charge here? Well, you know that you have 1 - 2 ion, and then you just have 1 ion, so you know that it must be chromium 2 oxide. And you can put that there. Copper 2 chloride, we saw this in the lab. So I'm putting the name. How do we know that that's its name? Is you have 2 -1 chlorine ions there. And so you know that basically you have a total charge of -2. And if you just have 1 copper ion, you know that the charge on that guy must be a +2. And so transition metals can form different ions, which is why you have to use the Roman numeral to describe what the charge is of that particular transition metal in that compound. Great. And then lastly, we can do one here. So when we are given chromium 3 chloride, we know that chlorine is going to form a -1 ion always. Chromium will be this guy. In this case, chromium is forming a +3. In order to have an overall neutral compound, it will be CrCl3. You need 3 of those chlorine ions to make it overall neutral. Gold in this case, so we have gold, its symbol is Au. We know that it's forming a +3 ion here. Similarly, chlorine is always going to form a -1, so we know that the formula here will be AuCl3. Where's a different one? Let's see. Oh, cobalt 3 oxide. So cobalt, in this case, Co, it's forming a +3. Oxygen, it's always going to form a -2. This one's a little bit harder. And so what you have to do is kind of think like, how am I going to get these to be appropriately matched up? And so the best formula here will be CO2O3. So that's going to be cobalt 3 oxide. And that would give the overall charge of +6, -6, and it would be neutral. So that's your answer there. All right, I hope that this was helpful. Feel free to check out the answer key, and yep, that's it.